Go outside tonight and look up. You'll see stars. But mostly, you'll see the space between them. Darkness. Empty, black, unremarkable darkness. That darkness is one of the deepest clues in all of physics. And for 400 years, nobody could explain why it's there. Because if the universe were infinite and eternal, that darkness could not exist. Every single direction you look should end on the surface of a star. The entire sky, horizon to horizon, should be a solid wall of blinding light. It isn't, and the reason why is almost certainly not the one you've been told. Here's the argument that turns this into a paradox. Assume the universe goes on forever, filled roughly evenly with stars. Now imagine a thin shell of space surrounding us. At some distance, stars in that shell look fainter the further away they are. Their light spreads out, and brightness falls off as 1 over the distance squared. But here's the thing. That shell is also bigger. Its volume grows as the distance squared. Move a shell twice as far away, and every star in it is 4 times fainter. But there are also 4 times as many of them. The two effects cancel. Exactly. Every shell, near or unimaginably far, delivers the very same amount of light to your eye. So stack up an infinite number of shells, and the light never stops adding. In reality, nearby stars block the ones behind them, so it doesn't climb forever. It saturates. The sky settles at the brightness of the surface of a star, not in patches, everywhere. There's a version of this you can picture with no math at all. Imagine standing in a forest that goes on forever in every direction. Look straight ahead. Your line of sight might slip past the first few trunks, and the next few, and travel a very long way. But in a forest with no edge, it has to hit a tree eventually. There are no gaps. There is no line you can draw that escapes. An infinite universe full of stars works exactly the same way. Every line of sight has to end on something burning. So the night sky should look like this. It doesn't. This is a genuinely old cold case. Kepler spotted the problem in 1610 and took the dark sky as proof that the universe must be finite. In 1744, a Swiss astronomer named Cheseaux worked the shell argument out properly. And in 1823, Heinrich Olbers restated it, which is why the paradox carries his name today, despite the fact that he was neither the first to pose it, nor right about the answer. Olbers thought that dust and gas drifting between the stars must be absorbing the missing light. It's the intuitive answer, and it's wrong. John Herschel took it apart. Absorbed energy doesn't just vanish. Dust that soaks up starlight gets warmer, and anything warm glows. Leave that dust sitting there long enough, and it reaches the same temperature as the starlight hitting it, and shines just as brightly as the stars it was supposed to be hiding. You cannot make a sky dark by putting something in the way. You can only change the color of the light. Which brings us to the answer you have probably heard before. The universe is expanding. Space itself is stretching. So light from distant galaxies gets stretched with it, shifted toward the red, drained of energy on the long trip to your eye. That's why the sky is dark. Case closed. Except it isn't. In 1987, a team of astrophysicists actually sat down and calculated how much of the missing light expansion could account for. The answer was a factor of about 2. 2. Not 1,000. Not 1,000,000. 2. If the universe stopped expanding tonight, the sky above you would look essentially the way it looks right now. Redshift is real, and it is nowhere near big enough to be the answer. So what is? The universe is young. To fill your sky with starlight, infinite space isn't enough. You also need time. Time for the light from those unimaginably distant stars to physically cross the gap and reach you. And when you calculate how much time that takes, the number is absurd. Roughly 10 to the 23rd years. Stars have been shining for about 10 billion. That's 10 to the 10th. We are short by 13 orders of magnitude. The sky is dark because almost all of that light simply hasn't arrived yet. And here's the part that closes the case for good. It never will. Stars run on nuclear fuel, and the universe contains a finite amount of hydrogen. Add up every star that has ever burned and every star that ever will. burning through every last drop of fuel, and it still does not add up to enough light to fill the sky. Not in 10 to the 23rd years. Not ever. The night is dark because the universe is too young to have lit it, and too poor to ever finish the job. Except, there's one more turn in this story, and it flips the entire thing around. The paradox rests on one assumption, that every line of sight ends on something glowing. And that assumption is completely correct. Look far enough out into space, and you are looking backwards in time. Look far enough back, and you reach an age when the whole universe was hot, dense, opaque plasma, glowing at around 3,000 degrees. There is no gap in it. There is no direction you can point that misses it. It's called the surface of last scattering, and you're looking at the universe 380,000 years after the Big Bang. So why isn't the sky on fire? Because in the 13.8 billion years since, space has stretched, and it's stretched that light along with it, by a factor of about 1100. 3,000 degrees cooled to 2.7 degrees above absolute zero. Blinding visible light became microwaves. Point a microwave telescope at any patch of sky you like, and there it is. A steady glow, in every direction, with no gaps anywhere. Now, to be clear, this is not the solution to the paradox. That light isn't starlight. It's older than every star that has ever existed. But the picture Olbers imagined, a sky with fire in every single direction, is real. He was right about the sky. He was just looking in the wrong part of the spectrum. So the darkness over your head tonight isn't nothing. It's a measurement. It's telling you that the universe has not been here forever, that it had a beginning, and that the light is still on its way. The night sky is dark because time itself had a starting line, and the fire from that starting line is still arriving.